All right. So for your study sheet, okay, I will just say for type B regressions. Type B is the ones you have to come up with your own points. So I'll just say first step is figure out the max, the mid, and the min. Okay, that would be step one. Step number one. Step number two, figure out the period. Okay. And then note, right? If it's half a period, then just go period is 2 times, right? Just make sure you know that one. If you have, let's say, 10 revolutions per minute, that's giving you multiple periods, right? Multiple cycles. So just one period would be minute. So let's go seconds divided by 10. So that'd be 6 seconds per revolution. So that would be your period there. So if that ever happens, oh, I missed something here. And you may remove things. And then you need to figure out the X scale. And the X scale is period divided by 4. Very important. I'm going to highlight that X scale. That's basically the main reason that you're finding the period, because you want to split it into quarters to find 5 points. Okay. And then question 3 is, where do you start? And 2 questions you have to ask yourself. Is it, are you starting on the low, on the mid, or on the high, or max, I should say? Right, this is the first part. You need to identify which line are you starting, on the low, mid, high, and B, time. Okay, is it time 0, time 2, etc.? Like where are you starting? And then come up with 5 points. It's getting a little bit too much here in my opinion, but essentially what you want is 5 consecutive points, and not always like that, but 5 consecutive points that you need. And you can make this a lot smaller. Maybe you can save a little bit of space up here on step 1. It's like find the max, mid, min. You can just have it written. I don't know if you need this extra, like this part right here that is going to be orange. I don't know if you need that on your study sheet. You might just remember that part. If you forget, you're going to probably freeze up at times on the exam. I hope you don't, but just move on, come back. Remember, if you have an equation, there's always 4 things you can find out: the min, the max, the mid, the period, right? Those things you can always find out. So if they ask you weird things about a sinusoidal, find those things, and most likely they're going to answer your question. Okay, so that's that. All right, let's figure out the equation for this scenario here. I'm going to scroll down. So I'm already giving you a little bit of a heads up here. Half a period given, and time does not start at 0. That's what I mean with that. So let's read it. The height of the water in a bay varies sinusoidally over time. on a certain day off the coast of Maine, the high tide is 10 feet, so the high is 10, and it occurred at 5 a.m. The low tide is 2 feet, and it occurred at 1 p.m. Write a model for the height and feet of the water as a function of time. Hours since midnight, we're talking here. So let's go through these steps here. So for A, let's figure out these three heights that we need for the sinusoidal function. In this case, they give us the high. They just flat out tell us that this is 10 feet. The low tide is 2 feet, so they give us this as well. If you remember the example from yesterday, they gave us just one. They gave us the lowest point, but they gave us the diameter of the wheel, so we were able to just add the diameter to get to our max. And then we found our mid by doing some calculations, right? So let's do the mid. The mid is what? 10 plus 2 divided by 2. That'd be 6 divided by 2, which is 3 feet. Oh, sorry. 12 divided by 2 is 6, sorry. I was just going to say this. Okay, don't copy this down, obviously, but let's say you went with 3 feet. You're like, oh yeah, I'm doing good. You should always check, like, from here to here is what? 7? From here to here is 1. That doesn't make any sense. That's not mid, right? So that should be a flag. Thank you for catching that. This is 12, right? 12 divided by 2, that's 6 feet. So let's check now. That's 4 this way, and it's 4 that way. Now we're talking, okay? So that's step number 1. Figure out those 3. What's the period? Sometimes you don't know it off the top, okay? Let's see here. It says that a high tide of 10 feet occurred at 5 a.m. and a low tide of 2 feet at 1 p.m. So we're told that we're at a high tide when time is equal to 5. So we're not starting at time is equal to 0. It's almost like we're just waiting for the tide to be on the high point, and it happens to be 5 seconds from the very start. So we're at the 5-second mark, 5-hour mark right here. Since you're at the high, it just stands to reason that you're going to go down from there and back up again. So this is what's happening. These are the 5 points we need to determine. Do we know the period by any chance in this case? Do we know the full, like, the time it takes to come back up to the high? We don't. There's nothing given. But we do know that the low, the first low, happens at 1 p.m. What are we going to use if it's 1 p.m.? We're going to use 13, right? That's right. It's 13 hours since midnight. Okay. So we know that over here, time is 13. So basically, we have half of a period right there, right, from here to here. So to figure out the period, we're just going to go 2 times 13 minus 5. Figure out how much time has gone by. And that's 2 times 8. So that is 16 hours. That is how long it takes to go from a high to a high. Okay. So if this is 5, what's this going to be over here? What time are we going to be at when we come back up? We go 5 plus 16, right? So 16 plus 5, that is 21. We're at 21 there. We're at 13 here. So we only have those 3 times so far, but that's where I go with the X scale. To find the in-between, or just in general, X scale is the way to go. You divide always by 4. Divide the total period in quarters, okay? 4 hours, okay? This is worth circling. This is important. So that means that as I jump from one line to the other, in this case, 4 hours will go by. Okay. So 5 here, this would be what? This would be 9. Plus 4 is 13. Plus 4 is 17. Plus 4 is 21. So you've used this. Let's highlight it. Right? Every time you move from a min or a max to a mid to a min, every time you're going to increase your x by this amount. Okay. So let's come up with our points now. Time and height. What is our first point here? 5, right? 5 and 10 feet. Then we're at 9 and 6 feet. Then we're at 13 and 2 feet. And we are at 17, 6 feet. And last but not least, 21, we're back to 10 feet. Okay. So you type this into L1 and L2, and let's come up with our sinusoidal regression. So type that in. I find sinusoidal regression if you go arrow up and you get to that much faster. Alpha, trace, sorry, not yet. Second 1, comma, second 2, comma, alpha trace, enter. There you have it. 4 sine of 0.3927x minus 0.39 plus 6. This is all that work just for this. And I am going a little overkill. There's way too much on there. After a while, you're probably not going to show all these steps. But that's where practice is going to come in today. So B. Let's answer B now. It says, what's the height of the water at 3 p.m.? So we're going second trace value. X is going to be 15 hours, right? So let's see if you can find this on your calculator here. I know certain things about the window. I know that my period is 16, so I'm going to go 3 times 16 on my x max. I'm going as low as 2, so I'm just going to go -1 for my y min, and as high as 12 for my y max. Just base it off the numbers you have. There you have it. And so just second trace value, x is equal to 15, and there you have it, 3.17 feet. Question, what are we assuming here? This is with respect to what? There's always something that we're basing our measurement off of. This would be the ground, right? Like based off the ground or some sort of measuring point. Because it's a high tide, it's write a model for the height in feet of the water as a function. It's the height off of the ground. Right, 317 feet off the ground in this case. Sometimes there's a reference point, so you could actually go minus because you're going below that marking on the shoreline perhaps. So that's different in that case. C, let's answer that one. And then you can, once we're done this one, I want you to try a couple on your own. How long does the tide stay at or above 8 feet within one cycle? I hope you know this one. 8 feet, right? Second, trace, intersect, and we're gonna find our 2 times we're at 8 feet within one cycle. So y2 is equal to 8. So watch this, just listen carefully how I do this. To me, if you look at my pencils here, if I just focus on these 2 mins, anything that happens between these 2 minimums is one cycle. Okay, guys? So you pick anywhere you want. So that means that I just have to worry about this little cap here. So I'm going to find these 2 times and subtract them, and then I get the time within one cycle. So time 1, second trace 5. You know what? Let's find the ones way over here. Why not? It doesn't matter. It doesn't matter which 2 you find, you're going to get the right answer. 2.333. Time 2 is 7.6667. So delta T. It's happening for, does it say above or below? Sorry. It does. Whew. Okay, good. We're good. Thought I got it wrong here. 7 point. And if you want full marks, make sure you use more than just 2 decimals when you write these down. And what are we in? This is our time is in hours, right? So it's 5.33 hours. And your favorite, your domain and range. My domain, we can't really have negatives here. So midnight is 0, and yes, it can go on forever. Range, this is very particular to a sinusoidal where you're just in between 2 values, right? So we're going as low as 2 feet, as high as 10 feet. And there you have it. That's your domain and range. Sometimes the domain and range, they are a bit weird with their wording. Sometimes they will say, what is a restriction on your range? They'll talk about restriction. If you think about it, there is a restriction on your range, and it's like it can't be lower than 2 or higher than 10. This is a restriction. Right? So if they say it that way, don't worry about it. It's just they sometimes use a little different terminology than we are. Okay. I want you to try 37. Right now, we're not going to go in groups just yet. I want you to just try 37. And let's say this, any graphing or any sketching, we're not going to worry about it right now. We're just going to worry about coming up with this equation. I can almost put money down that if you're going to make a regression on the exam, they're not going to ask you to graph it. They're just going to say, come up with the equation. Because it's going to be a nightmare. If you get your equation wrong and then you graph it, it's just not going to. It's going to be a nightmare to mark that and to be fair to the marking. So let's focus for now on just coming up with the equation. So go to 37, read it, and see what you get.